Think about all the stuff around you, your phone, maybe your desk. Ever wonder how it actually gets made? And then somehow ends up with you.
It's definitely more complex than it looks on the surface.
Right. And way more fascinating, honestly. Today, we've got a great set of materials from The Learner, and we're going to sort of pull back the curtain on this hidden world.
The world of operations management.
Exactly. We're diving deep into it.
And it's really, the engine room of any organization. It's how they actually create and deliver whatever it is they offer, goods or services.
Taking inputs.
Raw materials, people's time, tech.
And turning them into outputs efficiently. That's the core idea.
That's the core idea. And the Learner's sources are really comprehensive. We've got foundational principles, product design details, supply chain stuff, even the service side.
Yeah, it's a good mix. So our mission today, pull out the key insights, the really interesting bits, to give you, our listener, a solid handle on operations management without, drowning in jargon.
We'll try our best.
We'll touch on history, modern strategies, the crucial goods versus services difference. And luckily, we have our expert here to help connect the dots.
Happy to be here. It's interesting. Operations management sounds quite modern, doesn't it?
It does, yeah.
But the underlying ideas, they go way back. Think Adam Smith, 1700s.
The vision of labor.
Exactly. Breaking down tasks into smaller, specialized bits to boost efficiency. That principle, still absolutely fundamental today.
Okay, so boiled down.
Yeah.
Operations management is taking inputs, turning them into outputs smartly. So customers are happy and resources aren't wasted.
That's a great summary. The two big goals are customer satisfaction, getting them what they need, when they need it, at the right cost, and resource utilization.
Using your people, materials, machines well.
Right. Getting the absolute maximum effect from resources, as one of the sources puts it, minimizing waste, maximizing output.
And this field didn't just appear yesterday, right?
Yeah.
You mentioned Adam Smith. Who else really shaped it?
Well, moving into the early 20th century, you have Frederick W. Taylor, F.W. Taylor.
Scientific management.
That's him. He really tried to systematize efficiency, studied work processes meticulously.
The time and motion studies.
Exactly. Finding the single best way to do a task, standardizing procedures. It became much more analytical.
So from dividing work to timing every step.
Yeah.
All about making things better, faster, cheaper.
That was definitely the main driver. And the scope is huge. It covers that whole conversion process, inputs to outputs, making sure the customer gets value, but also hitting the organization's goals.
Like quality, cost, getting it there on time.
All of those, yes. Quality, cost, delivery, they're often seen as the big three operational objectives.
Okay, got it. So what are the key functions that fall under this big OM umbrella?
The sources lay out several core areas, things like deciding where to put your facilities.
Location, location, location.
Still matters. Then how you arrange things inside those facilities, plant layouts, material handling, designing the product itself, obviously crucial.
And then designing the process to make it.
Exactly. Process design. Then there's production planning and control, what to make, when, how much, quality control, of course.
Can't forget quality.
Definitely not.
Yeah.
Materials management, the whole flow stuff. And keeping the machines running, maintenance management.
Okay, plant layouts. You mentioned grouping machines versus assembly lines earlier. Can you elaborate just a bit?
Sure. So a process layout groups similar equipment, all the lathes together, all the welding stations together. It's flexible if you make lots of different things.
Like a custom job shop.
Right. But a product layout arranges things in sequence for one specific product, like a car assembly line. Much more efficient for high volumes of standardized stuff.
Got it. Different setups for different needs. Now, a really big point in the materials is the difference between goods and services. What's the absolute core distinction for operations?
It's fundamental. Goods are tangible, physical. You can touch them, weigh them.
Like a chair or a bag of chips?
Exactly. They provide utility. You can use them once or many times. And importantly, there's usually a gap between production and consumption. They can be stored, traded.
Right. I buy the chips today, eat them next week.
Yeah.
So how are services different?
Services are intangible. They're activities, performances, experiences, done for someone, often on demand.
Like getting legal advice or going to a movie.
Perfect examples. And the receiver, the customer, is usually involved in the delivery. You have to be there for the haircut. Evaluating service quality is also trickier, more subjective. And you can't really return a service once it's done. Ownership doesn't transfer.
Okay, intangible, customer participation, harder to judge. That makes sense. The sources had a table outlining these. What are the biggest contrasts operations managers grapple with?
Well, that tangible versus intangible nature drives so much.
Yeah.
Transfer of ownership, yes, for goods, no for services. Evaluation, easy versus complicated. Returns, possible versus not really.
Separability too, right? A good can be sold by anyone, but a service often depends on the provider.
Exactly. And variability, you aim for identical goods, but services often vary with each interaction. And the big one, storage. Goods can be inventoried.
Services can't. You can't stockpile haircuts.
You absolutely cannot, which makes planning incredibly different.
No warehouse full of, completed tax returns waiting for April.
Precisely, and that leads to another key challenge. Predicting demand for services is often way harder than for goods.
Because you can't just build up stock during slow periods.
Right. And because services so often involve that direct customer interaction, the service encounters mentioned in the sources, the quality of that interaction is paramount.
So how the call center agent treats you or how friendly the barista is,
Yeah.
that's part of the service
A
operation.
huge part. It massively shapes the customer's perception of value.
Yeah.
Every encounter matters.
Okay, that's a crucial distinction. Shifting gears to today, what characterizes modern operations management?
The focus is still strongly on efficiency, definitely.
Yeah.
Doing more with less, hitting high standards cost effectively, but also a deep, deep focus on meeting customer requirements.
Understanding what they really want.
And managing that whole conversion process, materials, labor, energy, tech to deliver it.
And it's not just about the technical side anymore.
Not at all. It's a blend. You need strong people skills, teamwork, communication. You need creativity for solving problems, rational analysis using data, and, of course, keeping up with technology.
It sounds like a complex balancing act.
Yeah.
The sources also mention some key modern concepts. Let's tackle BPR first, business process reengineering.
BPR, that was huge in the 90s. It's about taking a really radical look at your processes.
Not just tweaking.
No, often a complete redesign. Looking end to end across departments, maybe even into the supply chain and asking, is there a fundamentally better way to do this?
Often involving automation.
Yes, streamlining workflows, automating non-value added tasks. A clean slate approach, essentially.
Okay, radical redesign. Next up, reconfigurable manufacturing systems. RMS sounds futuristic.
It's pretty clever. RMS is about designing manufacturing systems to be adaptable, quickly and cost-effectively.
Adaptable? How?
In their physical structure, their software, their controls. The idea is you can rapidly change capacity or change what product you're making to respond to market shifts or disruptions.
Like a factory made of Lego bricks you can rearrange. Almost.
Sort of. The key is built-in flexibility. Our sources list 6 characteristics.
Okay.
Modularity, interchangeable units. Integrability, easy connection. Customized flexibility, flexible within a specific range, not for everything. Scalability, easy to ramp up or down. Convertibility, changing equipment function quickly. And diagnosability, finding problems fast.
How's that different from, say, FMS, flexible manufacturing systems?
FMS often aims for broader flexibility but can be more expensive upfront. RMS is about having just enough flexibility, the right kind of flexibility, exactly when you need it. More targeted, maybe?
Smart. Resource efficient. Okay, next. Six Sigma. Hear that term a lot. What's the essence?
Six Sigma is intensely data-driven. It's a set of tools, a methodology, really, for process improvement, aiming for near-perfect quality.
How near per...
The statistical goal is 3.4 defects per million opportunities, which is incredibly low.
Wow. Okay, so how do companies actually do Six Sigma?
Usually through structured projects using methodologies like DMAA.
Define, measure, analyze.
Improve, control. Right, that's for fixing existing processes. Or DMADV, define, measure, analyze, design, verify for designing new processes or products right from the start.
So a very systematic, numbers-based way to hammer out defects and improve performance.
Exactly. Reducing cycle time, costs, pollution, boosting satisfaction, profits. It touches everything.
And the last one in this group, lean manufacturing. I think Toyota, waste reduction.
You're on the right track. Lean is a philosophy, really. Maximize customer value, minimize waste.
What counts as waste?
Anything the customer wouldn't willingly pay for, the Japanese term is muda. Lean also targets muri, overburdening people or machines, and mira, unevenness or inconsistency.
And it came from the Toyota Production System, TPS.
Heavily inspired by it, yes. Sometimes called Toyotism. The core idea is that eliminating waste reveals problems. The lean tools are ways to address those problems.
So it's not just about cost cutting.
Not primarily. It's about value, flow, getting things right, minimizing inventory. And crucially, it involves everyone. Employee involvement, continuous improvement, Kaizen.
Culture is a big part of it.
Huge. Some say the cultural and management aspects are more critical than the tools themselves. The sources mention Toyota's DNA-specific rules about work, connections, pathways, and using the scientific method everywhere.
A really holistic approach.
Yeah.
Okay, zooming out, let's talk strategy. Operations strategy, what does that mean in practice?
It's about setting the big picture direction for how you'll use your operational resources, people, tech, facilities to support the company's overall competitive goals.
Making sure operations helps the company win in the marketplace.
Exactly. It needs to align. That's the idea behind the strategic fit framework mentioned in the texts.
So if you compete on low cost,
your operations strategy better be laser focused on efficiency. If you compete on innovation or customization,
then flexibility and quality might be the operational priorities. Got it.
right. And these decisions happen at different levels. Strategic long-term, big investments like new factories. Tactical medium-term like workforce planning. Operational short-term, daily scheduling.
And the main competitive priorities operations focuses on. You mentioned cost. What else?
Quality is huge, obviously. Dependability, delivering reliably, on time. And flexibility, adapting to changes, offering variety. These top-level priorities then get broken down into specific operational goals.
And weaving through all this strategy is the supply chain, right? How does supply chain management fit in?
Supply chain management takes an even wider view. It looks at the entire network involved in getting a product or service to the customer.
From the raw material supplier's supplier.
All the way to the final consumer. And everyone in between: manufacturers, transporters, warehouses, retailers. The goal is to maximize the total value generated across that whole chain.
A truly end-to-end perspective. Okay, let's talk warehousing within that chain. What are the operational basics?
Fundamentally, warehousing is about safe, scientific storage. Preserving the goods, maintaining quantity and quality.
So not just stacking boxes high.
Definitely not. It involves procedures for sampling, sealing, proper storage conditions, temperature, humidity control, maybe regular checks, pest control.
Right. Keeping things in good shape until they're needed. What about strategic choices, like owning your own warehouse versus using a public one?
That's a major decision. Private warehousing, owning and running your own, gives you lots of control. Good for specialized needs or high security. But it's a big capital investment.
And ongoing costs.
Right. Public warehousing is renting space in a facility that serves multiple clients. Much more flexible scale, up or down easily. Costs can be more predictable, often pay as you go. Less control, though.
Trade-offs, as always. Control versus flexibility and capital outlay. What about broader supply chain strategies?
Companies need to think about outsourcing models. Who does what? How risks are shared? The actual structure of the chain. Where are things made? Where are they stored? How many layers?
Network design.
Exactly. And the design of core processes like procurement, production, distribution, optimizing them for cost, speed, reliability, flexibility, plus the underlying systems, information flow, control, incentives.
And sustainability is becoming a bigger piece of this puzzle.
Absolutely. Connecting supply chain strategy to competitive strategy and environmental impact, energy use, emissions, waste. It's increasingly integrated.
Makes sense. Okay, let's rewind to the very start. Product design. What's its role from an operations view, beyond just looking cool?
It's critical. Good design isn't just creative fancy. It has to meet market needs, align with what production can actually make efficiently, using available materials and processes.
So design for manufacturability.
That's a huge part of it. And you also have to factor in legal, ethical, and environmental issues right from the start.
So it's really collaborative. Marketing, engineering, manufacturing, legal.
Ideally, yes. Key characteristics considered include the functional aspect. Does it do what it's supposed to? Operational, is it easy to use, maintain? Durability, reliability, and yes, aesthetic, styling, feel.
A far cry from Henry Ford's any color as long as it's black.
Absolutely. Modern production control allows for incredible variety now.
You mentioned legal, ethical, environmental issues. Give me some examples.
Legally, safety standards, avoiding defective products, ethically responsible sourcing, labor practices, transparency about things like GMOs maybe, environmentally life cycle thinking, using fewer materials, designing for reuse, recycling.
Designing responsibly, basically. Okay,
Generally.
product design. Now, how do we make it process planning.
Exactly. Determining how the product will be made. This flows into process strategy, the organization's overall approach to transformation.
Key principles there.
Fit the situation, match the process to the product and market. See individual processes as building blocks, and manage the connections, the interfaces between those blocks really well.
And the sources mentioned 4 main process strategies.
Right. Process focus, think job shops, high variety, low volume. Grouping, similar processes.
Okay.
Repetitive focus, assembly lines, medium volume, some variety. More standardized flow.
Like appliances.
Could be. Then product focus, high volume, low variety, continuous flow like chemicals or paper, dedicated equipment.
Very efficient for one thing.
Exactly. And finally, mass customization, aiming for high volume and high variety, using flexible systems to tailor things, like ordering a custom PC online.
Different strategies for different volume variety mixes. Now, a classic dilemma. Make it yourself or buy it from someone else.
The make or buy decision, fundamental stuff. It impacts cost, control, core competencies.
What factors drive that decision?
Cost is huge, obviously fixed and variable costs of making versus buying. Internal capacity, do we even have the ability to make it well? Control over quality and supply. Strategic reasons, protecting IP, keeping core skills in-house.
And avoid the sunk cost trap, right?
Yeah.
Just because you own the machine.
Doesn't mean making it is always the best choice now. You need to analyze objectively.
How do companies typically approach this?
Gather info costs, capacity, quality needs, analyze the numbers, then weigh the qualitative factors, control, supplier reliability, strategy, then decide. Sometimes they try to quantify the qualitative stuff too.
A balanced approach. Okay, let's talk physical spaces. Physical location. What goes into picking the spot?
Oh, it's critical. Big long-term impact. Factors include nearness to markets, cutting transport costs, being responsive, nearness to suppliers' reliable material flow, infrastructure availability, power, water, transport.
Labor is key too, right? Skills, wages.
Definitely. Government policies, taxes, regulations, climate sometimes, supporting industries nearby, and of course, the overall financial picture. There are even formal location theories and tools like factor rating to help weigh these up.
A complex decision matrix. Once you have the location, how do you arrange things inside? Facility layout objectives.
Minimize material handling, moving stuff costs money. Ensure efficient flow of work and people, use space effectively, build in flexibility for changes, and crucially, ensure safety and good working conditions.
And, like process strategies, there are different layout types?
Yes. Process layout grouping by function. Product layout sequential, assembly line style. Combination layouts. Fixed position for huge things like ships or buildings where the product stays put, and group or cellular layout grouping machines for families of similar parts, kind of a hybrid.
Again, depends on volume, variety, the building itself.
Exactly. Plus basics like lighting, ventilation, even employee facilities like restrooms and break areas are part of good layout design.
Location sets the map pin, layout designs the internal flow. Got it. Moving to day-to-day execution. Production planning and control. PPC, main goals.
Coordinate everything, labor, machines, materials effectively. Hit production targets. Keep things flowing smoothly and continuously. Deliver on time, cost effectively.
What are the key activities in PPC?
It's broadly planning and control. Planning involves figuring out material needs, MRP, process steps, routing, setting schedules, assigning work to machines, loading.
And control.
That's dispatching the work orders, tracking progress, follow-up, and intervening if things fall behind. Expediting.
Plan the work the plan, and fix it when it breaks. Are there different scheduling approaches?
Yes, depending on volume. High volume continuous flow needs line balancing. Intermediate batch production needs careful sequencing to manage setups. Low volume job shops need detailed order tracking.
And scheduling forward versus backward.
Right. Forward scheduling starts now and sees when it finishes. Backward scheduling starts from the due date and works back to find the start date. Tools like master schedules, shop schedules, and Gantt charts help visualize and manage all this.
Got charts again.
Yeah.
Okay, keeping the whole operation running requires maintenance. What are the goals of maintenance management?
Maximize equipment availability, keep things running. Maintain assets cost-effectively over their life. Ensure reliability and prevent surprise failures. Breakdowns are expensive.
And it's not just fixing things after they break.
No, that's breakdown maintenance purely reactive. There's routine checks, planned maintenance based on schedules, preventive maintenance to stop failures before they happen.
Like changing oil in a car regularly.
Exactly.
Yeah.
Then there's predictive maintenance using sensors and data to forecast failures, corrective maintenance for specific faults found, design out maintenance to eliminate the cause, TPM, total productive maintenance, involving everyone, and outsourcing options too.
Sounds like proactive is better than reactive here.
Generally, yes. Good planning and control and maintenance reduces waste, boosts productivity. The sources mentioned GLP, global labor productivity.
Okay, now how do we systematically improve how work is done? Work study and measurement.
Work study is the umbrella term. It's about examining work methods to improve efficiency. It has two parts. Method study,
How work is done.
right? Finding better ways.
Yeah.
And work measurement.
How long it should take.
Exactly. Setting time standards.
How does method study work? Is there a process?
Usually, yes. Select the job. Record everything about the current method using charts, diagrams. Examine it critically, challenge every step. Develop a better method. Evaluate it. Define it clearly. Install it. Train people. And maintain it, make sure it sticks.
Tools like flowcharts help with that.
Flow process charts, two-handed charts, multiple activity charts, flow diagrams, string diagrams for movement, even detailed SIMO charts. Plus principles of motion economy minimizing effort.
Very analytical.
Yeah.
And work measurement, establishing that standard time.
Often using time study. Select the job, break it into elements, ensure the method is good, measure the time for each element over several cycles, adjust the observed time based on the worker's pace performance rating to get a normal time.
Then add allowances.
Right. For breaks, unavoidable delays, maybe minor tasks, normal time plus allowances equals the standard time.
And that standard time is used for.
Comparing methods, figuring out staffing levels, planning production, sometimes even pay systems. It's a baseline.
Got it. Now, underpinning all this is materials. Materials management, inventory control, purchasing. What's materials management cover?
It's the whole flow planning, sourcing, buying, moving, storing, controlling materials, aiming for lowest total cost, continuous supply, high efficiency.
And inventory control is a big piece of that. Why manage inventory levels so carefully?
It's a balancing act. Too much inventory ties up cash, costs money to store, risks becoming obsolete. Too little risks stockouts, stopping production, losing sales.
So inventory helps buffer against uncertainty.
Yes, hedges against uncertainty, decouples operations, allows level production, maybe gets purchase discounts, but it costs. Inventory control finds the right level, using periodic or perpetual counting systems.
The sources mention EOQ, economic order quantity.
Classic model. Calculates the order size that minimizes the total cost of ordering and holding inventory. Finds the sweet spot where those two costs balance. Foundational concept, though real life adds complexity.
And ABC analysis, prioritizing.
Exactly. Categorizes inventory by value. A items are high value, few items high cost. C are low value, many items low cost. Focus control efforts on the A's where it matters most.
Makes sense. What about physically moving materials, handling equipment?
Big area. Lifting gear like cranes, transport like conveyors and forklifts, storage systems. Goal is efficient, safe movement. Minimize handling, use unit loads, automate where sensible.
Okay, and purchasing, it's more than just buying.
Much more. It's strategic sourcing. Planning, policy, supplier selection, negotiation, relationship management.
Objectives, getting the right everything.
Pretty much. Right quality, quantity, time, price, source material, transport, ensuring supply, managing costs, fostering good supplier relations.
Centralized versus decentralized purchasing.
Structure choice. Centralized gives buying power, standardization. Decentralized is more responsive locally, depends on the company. Techniques include tenders, JIT purchasing, vendor rating helps choose suppliers, value analysis seeks cost reduction without losing function.
Strategic supplier management. And once materials arrive, stores management.
Receiving, storing, issuing. Verifying shipments, proper storage, accurate issuing, record keeping, security, stock checks. The link between purchasing and production. Using different layouts, comb, tree, random, based on needs.
Keeping track of everything safely and accurately. Okay. Quality runs through all of this. Quality control objectives.
Improve reputation, customer acceptance. Reduce costs from defects and rework. Ensure interchangeability. Achieve optimal quality at good price. Satisfy customers. Inspect efficiently. Control process variation. Quality is affected by everything. Market, money, management, people, materials, machines, methods. The M's.
How is quality ensured? Inspection.
Inspection is key comparing to standards. Can happen on the floor, essentially combined. Functional tests, first piece checks, final inspection. Sampling is common check, a few to judge the batch.
It's statistical methods.
SPC, statistical process control. Using charts to monitor processes in real time, catch deviations. Acceptance sampling uses stats to decide on accepting batches. QMS, like ISO 9000, provide frameworks. And Six Sigma, as we discussed, is a major quality methodology.
Building quality in, not just inspecting it out. Okay, sometimes operations involve unique temporary efforts. Projects. How does project management relate?
It applies similar principles, planning, scheduling, controlling resources, but for specific time-bound goals. Projects have a life cycle. Define plan, execute, close. Operations managers often lead or join projects.
What's the project manager's role?
Oversee everything. Manage scope, team, communication, quality, time, budget. Needs leadership, problem-solving skills.
Tools similar to operations. CPM, PRT.
Yes, CPM and POIC are classic for finding the critical path, estimating duration, Gantt charts for scheduling. Control involves tracking progress, taking action. Techniques like crashing, adding resources to speed up, and resource leveling, smoothing resource use are specific to projects.
Focused application of ops principles for temporary goals. Finally, the big software systems. ERP, Enterprise Resource Planning. How do they fit?
ERP systems are integrated software suites. They aim to connect all functional areas, finance, manufacturing, HR, supply chain, CRM using a single central database.
Breaking down information silos.
That's the goal. Providing a real-time, unified view of the business. Implementation is a major project itself, involving selecting the right package based on fit, flexibility, tech, cost, time, skills needed, support.
The digital backbone for managing modern operations.
You could say that the central nervous system.
Wow. Okay, that was definitely a deep dive. From Adam Smith's pin factory to complex global supply chains and ERPs, operations management is just huge. It really touches everything.
It really does. It's fundamentally about the choices organizations make, constantly, to create and deliver value effectively.
And hopefully for you, the learner, this gives you a strong grasp of those core principles that make so much of our economy, our daily lives, actually function. Having that OM lens, it really changes how you see businesses.
It does. Which leads to maybe a final thought for you to chew on. Pick something you use every day, a product, a service, anything.
Okay.
Try to map out just mentally the operational steps behind it, getting the raw materials, making it, delivering it. Where do our OM principles fit in? What are the crucial stages? Where might things be inefficient, or where could innovation happen?
That's a great exercise.
Yeah.
Really makes you think about the hidden complexity. And if any specific area we talked about sparked your interest, the learner, or anyone listening, definitely dig deeper.
Look for real-world examples, companies doing it well, or maybe struggling. There's always more to learn.
Absolutely. Feel free to share any questions or insights. Until our next deep dive.